Assalamu alaikum dear students. We are starting with the topic that is our crystal lattice and the unit cell. What is crystal lattice? It is the arrangement of the constituent particles in 3 dimensions. Okay, that is your definition. Unit cell. The smallest repeating unit of the crystal lattice is known as the unit cell. So we are going to talk about different unit cells. Number 1, primitive unit cell. It has the lattice point at all the corners of a cube. So you are able to see those box-like structure, that is a cube, and at each of the corner 1/8 part of your particular constituent particles is contributing it over here. So that is your simplest primitive unit cell. If we talk about centered one, we are having 3: face centered, body centered and end centered. We are going to see each of them in detail. So that is number 1. First of all, we need to understand number of the constituents particles in each of the unit cell. Dear student, primitive में आप देख रहे हो बॉक्स के 8 कॉर्नर्स पे पर्टिकुलर पार्टिकल्स कॉन्स्टिट्यूएंट पार्टिकल्स कंट्रीब्यूट कर रहे हैं 1/8 पार्ट एंड टोटल वी हैव 8 कॉर्नर्स. So 1/8 multiplied by 8, that is equal to 1, means total if we sum up we are having 1 unit cell. If we talk about face centered, you are able to see that each corner contribute 1/8 part, and on the faces side we are having the circle in between, if you are able to see. So half of the portion inside and half outside. So half is going to contribute. So how many sides we have? Total 6 sides we have. 1/2 into 6 means 3 constituent particles, and 1/8 into 8, that is equal to 1. Means total face centered, how many constituent particles are there? 4. This is we have to remember, very important, because all this will be used in the numerical. 3. Body centered. See, 8 of the 8 corners are contributing 1/8 part, that is 1 constituent particles, and in the box, totally inside the box, there is 1 particle. So total body centered is having 2 constituent particles, and you are having 2 sides as a end, so each is going to have half. Fine, so that is 1 constituent particles, and 1/8 into 8, that is 1. Means it is also going to have 2 constituent particles. Dear student, this is very important to note down. You have to remember this, because this is all what you require in the numericals. They will not give you the values. They will simply give body centered, end centered and so on. So you have to remember how many constituent particles will be associated with which kind of the unit cell. Okay, if we talk about the 7 crystal system, so here in the system is given, also the unit cell particular, all the angles are given, along with that the examples are given. See, that is giving you the cubic, tetragonal, orthorhombic, monoclinic, hexagonal, trigonal, that is also known as rhombohedral, and triclinic. So herein you are able to see that each of the sides, along with that each of the angles are given, and also the examples are given. So in this particular slide you have to remember the examples, because examples are very important over here. So for cubic, as you are having NaCl and ZnS. For tetragonal you are having SnO2 and titanium oxide. So you have to remember the examples in this particular one. Then if we talk about, see dear student, if we talk about totally we are having 14 different lattices if we talk about the 7 crystal system. So herein you are able to see 14 Bravais lattice that are possible for the 7 crystal system. So herein you are able to see again CTOMHTT. That is again the short form given over here, and along with that you are able to see P is given, means primitive is possible, BCC, that is body center, is possible, and FC, that is face centered. So all the details is given, and that is what you have to remember. Now if we talk about the nearest neighbor distance, number 1, cubic cell, simple cube. Okay, so when we talk about the distance is equal to A, therefore radius is equal to diameter by half, that is D by 2. Therefore radius is equal to A by 2, and if we talk about A is equal to 2R. This is what you have to remember. This is very important. At the side, on the side where distance I wrote, I have given you the 2 circles. When we go for taking the half center of one to the half center of another one, and when we go for telling this distance as a, so we are having half of radius of both the circles. That is why A is equal to 2R. But how it is derived, that is I have shown you very clearly over here. Second, face center, same for face center also, what we are going to get the value of R, that we have to see. So what we are going to do, we are going to make one triangle. Here I have drawn one line with the pencil. So in triangle ABC, AC square is equal to BC square plus AB square. AC square is equal to A square plus A square. Therefore AC square is equal to 2A square. Therefore AC is equal to under root 2A. If we talk about the D is equal to AC by 2. AC कितना है √2 by 2 into A. Okay, this value again we are just changing the 2, जो 2 लिखा हुआ इसको √2 2 हो जाएगा. So just to cancel the numerator denominator we are just changing this. Therefore we are getting D is equal to A by √2. Therefore your radius will be D divided by 2. Therefore your R, when you get overall, that is equal to A divided by 2 √2. So dear student, again you have to remember, if you talk about A value, your A is 2 √2R. 2 √2 R is outside. So this is also you have to remember, very important, because again as I am telling you, this all will be required in your numericals. They are not going to ask you these derivations, but you have to remember these values. Derivations they may be not asking you, but only the values how we derive, that is what you need to know. If we talk about body center, again dear student, in body inside you are having one particular constituent particles. So we are drawing a line and we are making a triangle in order to obtain our R, that is radius. Therefore in triangle ADC, AD square is equal to CD square plus AC square. That is what you are getting. AD square is equal to A square plus 2A square. Therefore your AD square is equal to 3A square. AD is equal to √3A. D is equal to 1 by 2 AD. Therefore D is equal to √3 divided by 2 into A. Therefore your radius R is equal to D by 2. So what is the value of D you are getting? √3 divided by 2 into 2, we have written 2 times, into A. Therefore your R is equal to √3 by 4. So dear student, this is your value you have to remember. If we talk about in short, if we are talking about, so here I have given you one table, nearest neighbor distance, that is your simple cube, FCC and BCC, face centered and body centered cube, body centered cell also you can call it over here. So distance is given and radius is given, and this is you have to memorize. It is very very important one. Next to this we are also going to see the relationship between the edge length, that is A, and radius of this sphere R in the unit cell. FCC you have to remember, it is A 2 √2R. BCC you are having A is equal to 4 divided by √3R, and simple cubic A is equal to 2R. Dear student, try to memorize it and try to learn this one because this is very important. Next we are going to start with the